Let's embark on an adventure. Imagine if you could have a conversation with a library, a huge library filled with books on a variety of subjects, from everyday life queries to complex science theories. You ask it a question, and it responds by pulling together the most relevant pieces of information from all the books it has digested. This, my friends, is how we can start to understand large language models like GPT-4 from OpenAI, the digital equivalent of that imagined super library. A language model is a computer program that can understand, generate, and make predictions about human language. To explain it simply, let's say it's like having a conversation with a very well-read friend. Imagine a friend who's read millions of books, articles, and internet comments, and remembered it all. You could ask this friend anything, from "What's the weather like?" to "Explain quantum physics to me," and they would be able to provide a coherent response based on everything they've read. Now let's dig a little deeper. How exactly does a large language model learn and communicate? It's not that different from how we humans learn language as children. When a baby first learns to talk, they are surrounded by a world of sounds, words, and phrases. They listen and observe, picking up patterns in how words are used together and slowly learning to mimic and understand those patterns. Similarly, large language models like GPT-4 learn from vast amounts of text data on the internet. They process all these words and sentences, learning patterns in how words are used and follow each other. This process is called training, and it's a bit like that super library, constantly reading and learning. After training, these models can generate or complete sentences, answer questions, and even write essays. Just as a child learns to predict what word comes next when someone starts a sentence, these models also make predictions. For example, if I say, "The sun is shining and the birds are," you would probably predict something like singing or flying. That's what a language model does, but on a much larger and more complex scale. Let's take that idea a bit further and picture a giant game of fill-in-the-blanks. When we humans play this game, we draw upon our entire life experiences, the words we've learned, the contexts we've encountered them in, and the vast web of connections we've built among them. Now imagine an incredibly accelerated version of this game, where instead of one person's life experiences, the knowledge from millions of books, articles, and conversations are used to fill in those blanks. This is what a large language model does. When it sees a sentence with a word missing, it scours its learned patterns to predict the most likely word to fill that gap. It doesn't understand the sentence as we humans do. Rather, it plays this supercharged game of fill-in-the-blanks, using the patterns it's learned to generate a plausible completion. And it can do this for a single missing word, a partially finished sentence, or even an entire paragraph. It's this ability that allows it to generate human-like text, answer questions, and even write entire essays. Picture yourself in front of a massive jigsaw puzzle that spans an entire table. In this puzzle, every piece represents a word or phrase, and the image they create together represents a coherent, meaningful piece of text. When you start piecing the puzzle together, you consider the shape of each piece, the colors, and the small portion of the image it contains. You try to predict where a piece might go based on the other pieces already in place. This is similar to how a large language model operates. In the case of the language model, the pieces of the puzzle are the individual words in a sentence, and the assembled image is the coherent, grammatically correct, and contextually relevant statement. The model takes in the existing pieces or words, and based on the patterns it has learned during training, it predicts what the next piece should be. So, when it's given a starting point, say the beginning of a sentence, it can generate the next word, and the word after that, continuously assembling the puzzle until it has created a meaningful and complete picture or text. The more pieces or context it has to work with, the better its predictions usually are. However, just like us struggling with a particularly challenging puzzle, the model doesn't always get it right. Sometimes the piece it predicts doesn't quite fit, resulting in a statement that may sound a little odd or out of place. But most of the time, it does an impressively good job at completing the text puzzle in a way that's quite similar to how a human would do it. Now, why should you care about large language models? Well, there are several reasons. For one, these models can be incredibly useful tools for finding and generating information. They can answer questions on a wide range of topics, help generate ideas for a project or story, assist in learning new topics, translate languages, and even simulate characters for video games. Their versatility comes from their training on a wide variety of text from the internet. Moreover, these models can be great tools for accessibility. For people who have difficulty typing, or people who are visually impaired, voice assistants powered by large language models can help them navigate the internet, send messages, or read out text, making digital spaces more accessible for all. They can also help in the field of education, aiding teachers by providing detailed explanations of complex topics, helping students with homework, and even offering personalized tutoring on a wide range of subjects. It's like having a knowledgeable tutor at your disposal 24/7. But let's not forget that despite their intelligence, these models are not perfect. They do not possess understanding or consciousness like humans do. They only provide responses based on patterns they've learned from the data they were trained on. They don't have beliefs, opinions, or feelings. They can't experience the world or have a personal understanding of it. In conclusion, large language models like GPT-4 can be seen as conversational super-libraries. They ingest vast amounts of textual information, learn the patterns and structures within that data, and then use this learning to generate language-based responses. The applications are manifold and transformative, from enhancing accessibility to revolutionizing education. But as we integrate these tools into our lives, it's essential to understand their strengths, limitations, and the underlying mechanics of how they function. That way, we can harness their capabilities wisely and ethically.